In this video, I present you a very interesting project called as Vision Language Models Are Blind. In the last few months, if you have been following the AI closely, you might have noticed that there have been a lot of vision language models, starting with GPT-4 Vision, which have enabled numerous unprecedented image text processing applications worldwide. These vision language models can accurately identify objects in a scene and perform complex tasks based on these detected objects. For example, calculating the cost of drinks on a table from an image of the scene and an image of the menu of any dinner or lunch. These VLMs have advanced so quickly that describing unusual activities in an image, such as there is a flying man on the road, and they would detect that it is unusual. Existing vision language benchmarks cover a wide range of topics but only measure the overall humans versus LLM gap without pinpointing specific limitations for future vision research. Now, in this research, what these researchers have done is that they have tested VLM's ability to see on a low level vision tasks inspired by the visual acuity test given to humans by the optometrist. And the question they ask is, do VLMs perceive images like humans do? Short answer is no. But let's see the longer answer as what they have done. They have tested four state of the art VLMs: GPT-4o, Gemini 1.5 Pro, Claude 3 Sonnet, and Claude 3.5 Sonnet from Anthropic on their suite of 8 extremely simple visual tasks that involve only 2D geometric primitives like lines, circles, and squares, and they require minimal to zero world knowledge. I will also be showing you these tests, and we will also try one of the image they have used with GPT-4o in our live test. Their systematic experiments have revealed something very interesting, that vision of these VLMs is surprisingly like that of a person with myopia, perceiving fine details as blurry. That is quite interesting. Also, another very interesting finding was that VLMs can perfectly recognize a circle and a word separately. But when the circle is superimposed on the word, models tend to struggle to identify which letter is being circled. Another interesting finding is that VLMs can accurately count shapes such as circles that are disjoint and far apart. But all VLMs struggle to count interesting intersecting circles like in the Olympic logo. Also, all the primitive shapes like hexagon, circle, triangle, if they are superimposed, LLMs just fail. If you tile up squares into a grid, they will fail. When tasked with tracing colored paths in simplified subway, they fail. Anyway, so let's have a look at some of the tests which they have done, and then we will see how they have performed. So in their paper, they have listed down these 7 tasks they have performed with all 4 models, which I mentioned earlier. And on most of the tasks, the models have failed. So if I will drop the link to this project page 2 in the video description so that you can play along. So for example, if you click on task 1, so in the task 1, the task is to count these intersecting lines blue and red. And you see there are 4 variations of it, and first one is 0 intersection, second one is 1 and 2 and 2 intersection. And these were the questions which they asked from the model, that how many times do the blue and red line plot across each other, and then secondly, how many times do the blue and red line intersect, and ground truth is this, and random baseline accuracy is this for the people. Now results are, look at these results. So this is around the result for GPT-4o, Gemini, Sonnet, and then you can see average is quite low. Sonnet 3.5 is a bit better. Other than that, rest of them really sluggish. So VLMs, and these are the more representative. You see, these ones no one was able to do, and then this one, only this one, this Sonnet 3.5 was good, and then also this one Sonnet 3.5 was good. But other than that, most of them failed on most of the tasks. So if you go to other tasks, for example, let's look at task 4, Olympic one. So again, these are the prompts, and then it is in how many shapes are in the image. Answer with only the number in numerical format, like this one. These are the answers. But if you look at the qualitative samples, again, Gemini 1.5 Pro predicts 5 circle. Other than that, rest of them have just terribly failed. How interesting is that? Now, if you look at the another test here, let me go up quickly. For example, look at this task 7. This is the most complex one, where also they have done some variation. You might have seen this in your metro or subway map. So these are the prompts, and then look at the ground one, and then look at here. So surprisingly, some of them have failed, but VLMs have performed really worse in all of them, most of them. So look at this one, the very last one, all of them failed. Even this one only, this Gemini 1.5 Pro was okay, which is surprising that it got it right. Okay. Another cool thing is that if you want to draw these shapes by yourself, from this project page, you can go to their GitHub repo, and they have shared some of the notebooks through which you can generate these images if you want to test them out. So what I have done is I have just picked one of the image, and then this is my GPT-4o, and in this one I have given it this one image uh, from their project page. Let me paste the prompt here, and then we will test it out. So from their project page, in the first task, you see this is a one intersection. This is what I have grabbed. Now I am going to ask this question first, that how many times do the blue and red line plots cross each other? So let me copy it from there. Let me go to ChatGPT GPT-4o and then paste it here, and let's run it. So I'm just going to let it run and show you. Let me make it slightly bigger. Okay, much better now. Okay, so you see it has successfully done that they cross each other once. So if you go to there, this one, so ChatGPT, this one, I think it has successfully worked here. Okay, let's ask it another question. How many times do the blue and red line intersect? Let's see. Let's hopefully it will be the same chat, so it will be able to do with the same image. Let's wait for it to come intersect once. So this is good one. So let's me grab one image which they have failed to do so, and then we will check out the result. Now if you look at this task where they have checked it, that the Olympic logo, how many circles are in the image, answer with only the number in numerical format. On this first one, GPT-4o has failed. It has given it 5 circles, whereas there are 6 circles in the logo. So let's ask the same question live to see what it does. So same image I have uploaded here, and by the way, the image they have on their site is SVG, whereas I have converted it to JPG. There you go. So 5, totally wrong. These are 6 circles. Okay, that's wrong. There are, maybe can you try again? Let's see what it does. There you go. So second time it was able to detect it. Anyway, so but interesting finding, to be honest. I mean, we have started to trust this AI so much. So this is another reminder that we have to be careful, and then whatever AI is producing, we have to double check. We have to put in guardrails in place. That's it, guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thanks for watching.